Well, hello everyone. It's been a quick minute since my last video, but it's time we continued with electronics for beginners. And today we're gonna talk about resistors. I've gathered here quite a few resistors, and I'm gonna show them off and explain what they're doing, what they used. Now, what are resistors, you may ask? Resistors are basically components that you put to restrict the flow of current and the flow of power through a circuit. Now, resistors come in different shapes and sizes, as you can see here. Now, you can find average sized ones like this one, or you can find very small ones, which I there we go, like this one, which is very small. Come on. And there are multiple types, but they all do the same thing: restrict the flow of power through a certain section of circuit. Now, if I get a PCB, which I should have laying around here, right? I got myself a PCB from a UPS, if I remember correctly. You can see there are a lot of resistors in here. Resistors usually you will find in this type of axial package, but they can also come in this kind of package where they are encased in ceramic, and they are used basically everywhere. There is no one point where you can find a resistor specifically. They can be used for power reduction, voltage, as a voltage drop, or a voltage reference, or a lot of places. But yeah, they restrict the flow of power basically. Now, there are a lot of types of resistors. The most common one, as shown earlier, it's this type. I don't know if the camera focused, but it's this little axial package. These are non-variable resistors, as they're called basically, as they're known, which means they technically and ideally always have a fixed resistance. Now, if you want to find the resistance, you can either go with the color code, which I should have a chart around. Well, my printer decided to cut off the sides, but you know, this is a resistor chart. This is how you can find out the values of this type of resistor. You see there are colored bands on it, and there each color means a certain value. Like here are some examples: red, yellow and brown with a gold. At the fourth band, it's a 240 ohm resistor with 5% tolerance. And there are multiple types of band resistors, like 4, 5 and 6 band resistors. As you can see here, there are the first 3 if it's a 5 band, or the first 2 if it's a 4 band. It's gonna be the actual numbers. And first of all, the way you usually find which band it's last, it's usually the thinner one, if I remember correctly, or if it's just some resistors that you found around, you can look for the the silver and the gold, the colors, they are pretty much only used as the tolerance value. You almost never find them as a multiplier, and that's the only other place you can find them. So that's how you usually find the value of a resistor. But you actually, what you're supposed to do, well, not supposed to do, but what it's easier to do is to just get a multimeter and measure it. So let's say this resistor, if you just go like this, it's gonna tell you the straight up value, which is gonna be usually pretty close. So yeah, that's pretty much the best way to measure them. It's quick and it's easier to just do it than having to do the whole calculation, the first and then the second, then multiply. Like here, let me explain how you actually find the value. The first two values, you basically put them next to each other. Let me get the notebook. So here, get out the way. To find the value, what you do, it's, let's say here, we're gonna use this one because it's smaller and doesn't take up the whole screen. Let's say you have a red, brown, red. The first digit, it's red. Red, it's 2. You're gonna do 2. Then black. Black, it's 0. You put 0 right next to each other. And then if you have a third digit, you put it here. If not, you just multiply by the multiplier, which means how many zeros you need to put next to a 1. So if it's 2, it means you put 1 and then 2 zeros, and that's how many ohms you get, which will equal 2000 ohms, which is also equal to 2 kilo ohms. And that's basically how you find out the value of a resistor using a color chart. So yeah, it's pretty simple. If you can remember the chart, it's gonna come natural. But yeah, that's how you find out by the colors. Again, I would just say get a multimeter, put it into the ohms range and just measure it. It's gonna be just easier. Now back to different types of resistors, huh? Again, the most basic types are these. These come in multiple flavors. It's not really a standard or anything, but usually these beige ones are carbon film or carbon based resistors, which usually have a pretty high tolerance, but they're cheap to make and cheap to get, so that's why you'll find in non-significant, non-precision places. The next ones are these ones, which are blue. Again, it's not a standard, but that's just what I found out myself. If it's blue, usually, but not always, it's gonna be a higher tolerance one, and usually it's gonna be a metal oxide film resistors, which are exactly what they're made of. They're just a metal oxide film that's been cut to get a certain resistance. And it's just higher precision. That's just how it is. Now you can also find them in smaller or bigger packages, as I said earlier, like these. But there's another type, which is S&D resistors, which I probably will make a photo after, but are the little ones here or here, which are very small. And I don't know if you can actually see. And these. And the way there are multiple standards to figure out what value they are, but I'll probably put some chart on screen. Now, those were basically fixed value resistors. Now, there are also variable resistors, which they change how much resistance they have based on certain conditions. Here it's a potentiometer, which I dropped. It's a 500K one, which means it's 500 kilo ohms. But it's just between these two. These two pins, the outside ones, will have that certain resistance. The middle one will have a different resistance based on the position. If it's all the way here, from here to here is gonna be least possible resistance, from here to here is gonna be the highest possible resistance. And you will find these as volume knobs or just they're used as human input for different circuits. They come in different sizes. This one is a chunky one, as I call them. There's also this style, which are supposed to mount like this. Then there's this one, which is a trimmer, as it's called, or precision potentiometer, because they take more turns to change the value significantly. This one is like 270 degree for a full sweep. This is like 30 turns to get from the lowest to highest possible value. Now, there are imposters that look like this but aren't actually potentiometers. And the imposter, it's this one. You may think, oh, it's just a different package of potentiometer, but no. If you spin it, you will see it spins constantly. It doesn't have an end. You could go like this for hours on end and you will not find a end stop or anything. This is a rotary encoder. It still has 3 pins. It still has a place which you spin it by, but it's not a potentiometer. It's a completely different thing, and it's not gonna go very well if you use one of these instead of one of those. So be careful. If you don't find a ohms value and it doesn't have an end stop, it's probably an encoder. You can get very easily fooled by one of these. And yes, this is the only one I found. I'll put a photo of ones in these styles. And talking about potentiometers, there's also stereo ones, as they're called, or double potentiometers. We have 2 sets of wipers, which you can get you can use two different signals to get different outputs using the same knob, basically. These are pretty specific, but they can also get in these styles, which actually have a contact which closes and opens based on what position it's in. This is from a power tool that I tore it apart. It's a 500 kilo ohm potentiometer, and when it reaches the end, it shorts the outputs together. So not the outputs, but it shorts these pins together, so the power tool knows to go at full power and don't do any speed adjustments. Now, another type of resistors you may find that are also variable are these. This one is a NTC thermistor, which negative temperature coefficient thermistor, which changes their resistance based on temperature. Now, this one was actually used as a inrush current protection. So if a lot of power comes in at one point, it's gonna heat up and reduce its resistance to allow more power through. Was it? No, that's PTC, sorry. I'll just cut it out. But they are used as protection in certain situations, and they can also be used as temperature probes, but they usually come in a smaller package like this one. But those are the thermistors. They come in positive temperature coefficient and negative. Negative means as temperature increases, the resistance goes down, and for positive, it's the opposite. Now, there's also photoresistors, which decrease their resistance as more light hits them. So they are used as night lights or light sensors. That's just what they're usually used for, to either turn on a light or tell some circuit it's nighttime or a light is off or something. Now, another type of resistors, these are MOVs. They are used as current protection, which, well, over voltage protection actually. They normally have a high impedance, high resistance, which means current is harder to pass through, but if voltage reaches a certain level, they're gonna very quickly change their resistance to be very low, and basically these are used to short the inputs if a very high voltage is passed through, and basically save the rest of the circuit by sacrificing this one. These are usually put on mains inputs and everything. Now, things that are also resistors, but they aren't usually called that, they are fuses. Fuses are also resistors. This one is a 30 amp fuse, which is just a resistor. When it reaches the specified amps, it's gonna just destroy itself. And even though these are called fuses, they're nothing more than glorified resistors that are made to break at certain points. And this is just your standard filament light bulb, which is also just a resistor at the end of the day. It has a filament which is gonna heat up due to resistance. And this is actually broken, but this is a linear voltage regulator. These are basically just smart resistors. They increase or decrease their resistance based on the input voltage to get a stable voltage output. And yeah, these are basically most types of resistors that you'll find around. And thank you for watching. Oh, actually, before I go, something that may be useful when measuring resistors is one of these little testers. You can just put a resistor in, close it, and it's gonna tell you a relatively accurate measurement of the resistor. But yeah, that's this episode about electronics basics, and I hope you enjoyed it. And if you have any suggestions for a next video or any feedback, just leave it in the comments below. Bye!